Hello students, let me introduce the chapter on differential equations. I shall be discussing the following points in this chapter. First point, introduction. Second, basic concepts. Third, general and particular solution of a differential equation. Fourth, formation of a differential equation whose general solution is given. Fifth point, methods of solving first order and first degree differential equation. Let us look into the introduction. We have already discussed how to differentiate a given function f with respect to an independent variable, that is, how to find f dash x for a given function f at each x in its domain of definition. Further, in the chapter on integral calculus, we discussed how to find a function f whose derivative is the function g, which may also be formulated as follows. For a given function g, find a function f such that dy by dx is equal to g of x, where y is equal to f of x. An equation of this form is known as differential equation. In modern science, the role of differential equations is very important. It has been used to discuss the various laws of physics, chemistry, biology, geology, economics, etc. Sometimes we can express the relation between certain variables in the form of differential equation. In engineering, physics, chemistry, and sometimes in subjects like economics, biology, etc., it becomes necessary to build a mathematical model to represent certain problems. It is often the case that these mathematical models involve the search of the unknown function or functions that satisfies the equation which contains the derivative of unknown function or functions. Such equations are called differential equations. As we have seen, differential equations arise in a variety of applications, may it be in physics, chemistry, biology, geology, anthropology, economics, etc. Hence, an in-depth study of differential equations has assumed prime importance in all modern scientific investigations. In this chapter, we will study some basic concepts related to differential equations. We shall also discuss general and particular solutions of a differential equation, formation of differential equations, some methods to solve a first order, first degree differential equation, and some applications of differential equations in different areas. Let us look into the basic concepts. We are already familiar with the equations of the type x square minus 3x plus 3 is equal to 0, sin x plus cos x is equal to 0, x plus y is equal to 7. Let us consider the equation x into dy by dx plus y is equal to 0. We see that equations 1, 2 and 3 involve independent and or dependent variables, but only equation 4 involves variables as well as derivatives of the dependent variable y with respect to independent variable x. Such an equation is called a differential equation. In general, an equation involving derivative or derivatives of the dependent variable with respect to independent variable is called a differential equation. A differential equation involving derivatives of the dependent variable with respect to only one independent variable is called an ordinary differential equation. For example, 2 into d square y upon dx square plus dy upon dx whole cube is equal to 0 is an ordinary differential equation. Please note that we shall prefer to use the following notations for derivatives: dy upon dx as y dash, d square y upon dx square is equal to y double dash, d cube y upon dx cube is equal to y triple dash. For derivatives of higher order, it will be inconvenient to use so many dashes as supersuffix. Therefore, we use the notation yn for nth order derivative, that is d raised to ny upon dx raised to n. Now, what do you mean by order of a differential equation? Order of a differential equation is defined as the order of the highest order derivative of the dependent variable with respect to the independent variable involved in the given differential equation. Consider the following differential equations: dy by dx is equal to e to the power x, d square y upon dx square plus y is equal to 0, and d cube y upon dx cube plus x square into d square y upon dx square whole cube is equal to 0. The equations 1, 2 and 3 involve the highest derivative of first, second and third order respectively. Now, what do you mean by degree of a differential equation? To study the degree of a differential equation, the key point is that the differential equation must be a polynomial equation in derivatives. By the degree of a differential equation, when it is a polynomial equation in derivatives, we mean the highest power positive integral index of the highest order derivative involved in the given differential equation. Now, let us take up an example. Determine the order and degree of the following differential equations. First, d raised to 4y upon dx raised to 4 plus sin y triple dash is equal to 0. Second, ds upon dt whole raised to 4 plus 3s into d square s upon dt square is equal to 0. Third, y triple dash square plus y double dash cube plus y dash raised to 4 plus y raised to 5 is equal to 0. Fourth, y double dash plus y dash square plus 2y is equal to 0. Now, look into the solution. In the first case, the highest order derivative is d raised to 4y upon dx raised to 4. Therefore, the order here is 4. As the given equation is not a polynomial in dy upon dx, therefore, its degree is not defined. In the second case, the highest order derivative is d square s upon dt square. Therefore, the order is equal to 2 and the index of d square s upon dt square is 1. Therefore, the degree is equal to 1. In the third case, the highest order derivative is y triple dash. Therefore, order is equal to 3. Index of y triple dash is 2. Therefore, the degree is equal to 2. In the fourth case, the highest order derivative is y double dash. Therefore, order is equal to 2 and index of y double dash is 1. Therefore, degree is equal to 1. Now, let us take up one more example here. Verify that the given function is a solution of the corresponding differential equation in both the cases. First one, y is equal to e to the power x plus 1 for y double dash minus y dash is equal to 0, and second one, y is equal to cos x plus c for the equation y dash plus sin x is equal to 0. Look into the solution now. The given function is y is equal to e to the power x plus 1. That implies y dash is equal to e to the power x and y double dash also is equal to e to the power x. That implies y double dash is equal to y dash. That goes y double dash minus y dash is equal to 0. Therefore, first equation is a solution of the given differential equation. In the second case, y is equal to cos x plus c. This is the given function. We calculate y dash is equal to minus sin x. Hence, y dash plus sin x is equal to 0. Therefore, y is equal to cos x plus c is a solution of the given differential equation. So, students, remember, order and degree, if defined, of a differential equation are always positive integers. Now, it is the time to give you your home assignment. Take down the question. Find the degree and order, if defined, of each of the following differential equations. First equation, dy by dx minus cos x is equal to 0. Second equation, xy into d square y upon dx square plus x into dy by dx whole square minus y dy by dx is equal to 0. Third equation, y triple dash plus y dash plus e to the power y dash is equal to 0. So, students, we learned today what do you mean by differential equations and also the order and degree of the differential equations. In the next session, we shall also study about general and particular type of differential equations. Thank you.